Okay, here you see that the water is high here on this side of the dam and low on the other side of the dam. And just like everything else in nature, water wants to go from high to low. This is a very powerful force. Gravity pulls down on the water, and as gravity pulls down on the water, we use it by tunneling the water, forcing the water to go through a tunnel, man-made tunnel that rolls the water down. Because water flows from high to low, it flows fairly quickly and turns the turbine. That turbine turns electromagnets. Those electromagnets turn and make electrons flow down the conductors. Those electrons flowing the conductor, you know it as electricity. And that's how we make electricity using hydroelectric power. We have to have hot water at a very high position and a place for the water to go to a very low position in order to get gravity to pull that water down and turn that turbine and make the electricity flow. Now, the same process is used in cells, but of course we're not using water to turn a turbine. We're using concentration gradients to turn ATP synthetase. So you can see here that we have a high concentration of hydrogen ions on one side of the membrane in the mitochondria that creates a high concentration on one side and low on the other. And because ATP synthetase is the only way the hydrogen ions can get out of that high concentration, it allows for the flow of protons through the synthetase molecule that then drives the formation of ATP, just like the water flowing over the dam actually moves the electrons down the wire. So the protons in this case move through the ATP synthetase, allowing for ATP to be made. The way we get the protons to come from the side that has less protons into the side that has more protons is we use electrons to drive those protons into the higher concentration, because remember, we need energy to push things against the concentration gradient. So you see here that the ATP is ADP in this case is at yet an extra phosphate. It becomes ATP. That ATP has a lot of energy that can be used to drive chemical reactions in your body. They move from thinking to moving to chewing. The ATP goes everywhere, and so does the carbon dioxide. Carbon dioxide leaves the cell, goes into the bloodstream, gets carried through the blood vessels out to your lungs, where then exits. Remember the mitochondria, cut it open, and you can see oxygen's going in, and NADH, which is one of those things we've discussed already as an electron carrier, drives the protons into the area of higher concentration.